Okay, donkeys, let's do a little solution stoichiometry here, all right? So we've got this reaction of 75 milliliters of 0.125 molar silver nitrate with 25 milliliters of 0.075 molar magnesium chloride. Draw the reaction vessel after the reaction is complete. Ay, caramba. Well, first thing we notice is I have volume and I have molarity of one reactant and I have volume and molarity of a second reactant. Anytime I have both reactants, guess what kind of a question it is? It's a limiting reagent question. So let's write our reaction. I have silver nitrate, aqueous, reacting with magnesium chloride, aqueous. And what am I going to form? Well, it's a double replacement reaction. I'm going to form magnesium nitrate, aqueous, and silver chloride. There we go, and silver chloride is my precipitate. So I need to figure out which of these is my limiting reagent. So here's what I'm going to do. I want to figure out my moles of silver nitrate, and then I want to figure out moles of my silver chloride, assuming my silver nitrate is my limiting reagent. And then I'm going to figure out my moles of magnesium chloride. And then I want to figure out my moles of silver chloride again, but this time I'm assuming my magnesium chloride is my limiting reagent. Cool. All right, here we go. Let's do this. So how do I get moles? Moles are equal to what? Liters times my molarity. So I have 75 times 10 to the minus third liters. 75 times 10 to the minus third liters, because that was given to me in milliliters, so I'm going to change it to liters, and 0.125 molar. And let me grab my handy dandy TI-30XA. 75 times 10 to the minus 3 times 0.125, and 75 times 10 to the minus 3. Let's try that again. Times 0.125. How about 0.009375 moles of my AgNO3? So then, let's figure out how many moles of silver chloride I'd get out of that. 0.009375 moles of my silver nitrate times, what's my mole ratio? To go back and look, my mole ratio is what? Oops, here we go. My mole ratio is 2 to 2. So 2 moles of silver chloride per 2 moles of silver nitrate. And so I would get 0.009375 moles of silver chloride if all of my silver nitrate reacts. Now let's do the same thing with my magnesium chloride. I have how much magnesium chloride? 25 mils. So 25 times 10 to the minus 3 liters times its molarity. What was the molarity? 0.075. 0.075 molar. Good. So let's try that. 25 times 10 to the minus third times 0.075, and I get 0.001875 moles of my magnesium chloride. Cool. Now let's assume all that magnesium chloride reacts. If it is the limiting reagent, how much silver chloride do I get out of that magnesium chloride? Well, what's my mole ratio? Yoink, yoink, yoink. 2 moles of silver chloride per 1 mole of my magnesium chloride. And so times 2, and I get 0.00375 moles of my silver chloride if my magnesium chloride is limiting. So then I'm going to compare the amounts of silver chloride that each of my reactants would produce if they were the limiting reagent. And I find that this is the lesser amount, so this is going to be my theoretical yield, which means my magnesium chloride is going to be my limiting reagent. And how much of my silver chloride can I really produce? Well, then my grams of my silver chloride equal 0.00375 moles of silver chloride times 107.87 plus 35.45 grams per mole times 107.87 plus 35.45. Yoink, yoink. Let's try that again. 107.87 plus 35.45 times 0.00375, and I get 0.54 grams of silver chloride. Great. All right. So what have we learned? We've learned that my silver chloride is the precipitate, so it's going to be solid. We've learned that my magnesium chloride is my limiting reagent, which means that my silver nitrate is excess. Now I think I can draw my picture. All right, here we go. So we want to have my precipitate. Okay, let's go with some Ag plus, and my chlorine should be a little smaller than that. And then some more Ag plus and silver chloride and my chlorine like that, right? And why am I picking two? Well, because in my balanced equation, I had two formula units of silver chloride, so that's what I'm running with. Now, what doesn't dissolve? Well, what stays aqueous? Excuse me, not what doesn't dissolve. What stays aqueous? Well, my magnesium and my nitrate is still aqueous, so I need to have a magnesium floating around somewhere in here. So here's my magnesium, and I need some nitrates, right? So we'll call these our nitrates. And those are surrounded by my water. So should I use a different color for water? Okay, let's go with the red for my water. Let's put an oxygen there, and an oxygen there, and an oxygen there. How about an oxygen there, and an oxygen there? Oxygen, oxygen, oxygen. Okay, that looks pretty good. Let's throw some hydrogens down. So remember, the hydrogen side is going to be the positive side. So something along this line would be my picture. That's beautiful, right? Except for, what am I leaving out of here? I'm leaving out my excess reagent. What is excess? My silver nitrate is excess, so that means I have to throw in another silver and another nitrate that is not. There's my silver, and then let's put in a nitrate somewhere here. Okay, so these are my nitrates. Good, and that means then I need some more water. Yoink. Let's put a water here, and how about that's a little small for my water. Eee! Yoink. Let's put a water here, and a water here, and a water here, and how about water there, water there. And let's throw in some hydrogens. Yoink, 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 yoink. Remember, the hydrogen side's attracted to the nitrate, the non-hydrogen side's attracted. Boy, that guy looks like the devil, doesn't it? That's the devil. He's showing up in our as water. Or is that just Mr. Smith? I'm not sure. Good. So that's kind of what our picture should look like. You know, I need to have excess silver, excess nitrate. And now this will help us out in figuring out our last question, which is what is the concentration of each ion after the reaction has occurred. So when I look at my picture, what do I notice? Well, what's in solution? It looks like I have nitrate in solution. What else is in solution? I see a magnesium in solution, and I see a silver in solution. What do I not see in solution? My chlorides. They are not in solution. So what's the concentration of chloride? Essentially 0. Okay, so I have the easy thing done there. Now, here's my question. How much of my original nitrate stayed in solution? Well, hey, I see no nitrate down here in my precipitate, so I'd say all of my original nitrate is still in solution. Well, what was my original nitrate? Okay, so what did we start with? My original moles of silver nitrate were equal to what? What? My original moles of silver nitrate were right here, 0.009375. So I'd have 0.009375, and that's of my silver nitrate. So how many moles of nitrate did I start with? Well, 0.009375 moles of silver nitrate times my mole ratio, 1 mole of nitrate per 1 mole, yoink, of silver nitrate. And so I would end up with 0.009375 moles of nitrate. Well, how do I get the concentration of nitrate? Well, the concentration of nitrate is going to be my moles of nitrate divided by my total volume. And what's my total volume? Well, my total volume, my moles, hold it, 0.009375 moles of nitrate over what's my total volume? It was what? 75 plus 25 milliliters. 75 plus 25 milliliters looks to me like 100 milliliters. So let's go down here. Moles divided by 100, but I don't need milliliters, I need liters. So I have 0.009375 divided by 0.1, it turns out to be, and that's 0.094 molar. That is the concentration of my nitrate. Good. So we've taken care of 2. We know that my chloride is 0. We know that my nitrate, we just said was what? 0.94? 0.094. Now the next easy one is magnesium. How much of my original magnesium stayed in solution? So I'm looking at my picture. Here's my magnesium. Did any of my magnesium go into my precipitate? The answer is no. So that means all of my original magnesium stayed in solution. So what's the amount of my initial magnesium chloride? Moles of magnesium chloride were, let's look up here, 0.001875. 0.001875 moles of magnesium chloride. So how many moles of Mg plus do I still have at the end? It is 0.001875 moles of my magnesium chloride times 1 mole of magnesium per 1 mole of magnesium chloride. Piece of cake. So that's 0.001875 moles of magnesium, and I want to get my concentration of my magnesium. Whew, what happened there? Magic. Let's try that again. Concentration of my magnesium will be equal to my moles, 0.001875 moles, divided by what's my total volume? My total volume was 100 times 10 to the minus third liters. So I would get 0.019 molar. Cool. Zero. So my concentration of my Mg2 plus is 0.019 molar. And now the hard one. Why is my silver more difficult than everything else? Well, because some of my silver ended up in my precipitate and some of my silver ended up as excess. So what do I have to do now? I have to calculate the amount of excess silver nitrate. Okay, and how do I calculate the amount of excess silver nitrate? I need to calculate the amount of silver nitrate used in my reaction based on my limiting reagents. So I'm going to take my moles of magnesium chloride times the mole ratio of 2 moles of silver nitrate per 1 mole of magnesium chloride. All right, so let's do it. So moles of my original magnesium, I think is right here, right? 0.001875 moles of magnesium chloride times, what's my mole ratio? 2 moles of silver nitrate per 1 mole of magnesium chloride. Okay, so let's take that 0.00185 times 2 divided by 1, and that's, why did I divide by 1? Everybody knows that dividing by 1 makes no difference, right? 0.00375 moles of what? AgNO3, but that is AgNO3 that is doing what? It's being used in the reaction. So how much excess AgNO3 do I have? Well, I'm going to take my original amount. What's my original amount? My original amount is right up here, isn't it? My original amount of AgNO3 is 009375. 0.009375. That's my original. How much was used? 0.00375. So what do I have left? How about 0.005625 moles of AgNO3 excess? Okay, but we already know about my nitrate. We already figured that out. We figured out that all the nitrate stays in solution. So really, I'm really only interested in moles of my Ag plus that are excess. And that would be equal to my 0.005625 moles of silver nitrate times the mole ratio. I know this is elementary, but I like to do things so that you understand what's going through my mind, at least when it comes to chemistry. And so I'd get 0.005625 moles of Ag plus excess. So then what's my concentration of Ag plus? Well, it's going to be 0.005625 moles. And once again, I have to divide by my total volume, 100 times 10 to the minus third, which will be equal then to 0.056 molar. Cool. So there you have it. No, 0.056, right? 0.056 molar. And there's my answer. If you can do that, you can do just about everything I need you to do in solution stoichiometry. All right. If you have questions, let me know. Ciao, Bella.